dear student to the tetrahedron chemistry classes. So in the lecture series of ACE your reaction mechanism skills, today I am going to discuss another multi-step reaction, okay, in which you will use different kinds of the reagent. Definitely this is the usual practice in the multi-step reactions, and after the completion of this reaction you will learn a concept which is very important, the protection of the carbonyl group. Protection is generally used in the organic synthesis when we want to protect a particular group by the attack of a certain reagent, and after the completion of the reaction we will deprotect that particular group and that functionality will be reproduced in the molecule. Okay, so this is the problem where you have been given your this aldehyde, which is of course on the beta carbon substituted with the bromine. So this is the functional group, this is alpha carbon, this is beta carbon, and that beta carbon is having the bromine. That means beta halo aldehyde type of the compound is given here, and this is your ethylene glycol in presence of the sulfuric acid. Then you will get your A, then A will react with the magnesium in presence of the dry ether. Dry ether means moisture free, and whatever the product will result after the reaction of this A with the magnesium, then you will react that particular compound with the benzaldehyde. This is your benzaldehyde, pH stands for the phenyl, and then you will get the B, and that B will undergo the hydrolysis to give you the product C. Okay, so it is very important to learn the concept of the protection and the deprotection. So I am telling you, this ethylene glycol is a one way of protecting carbonyl group. So this ethylene glycol will protect. It is basically the protection used for the protection of carbonyl group. Please remember, right? It simply means that we will protect this carbonyl group by the attack of the reagent which we will use in the second step, right? And it simply indicates that when we are protecting this, that means after the completion of the reaction, that means in the product C, this group will be reproduced. This thing you should know, and we are doing this reaction in presence of the acid, right? So how the reaction goes, please see. Say this is my oxygen, this is my hydrogen again, right? This is my CH2, okay, and this is my another CH2, and this is the OH group, okay. And in the organic reactions, it is very important to know the concept of the lone pair on the residual or the formal charges present on the atoms, right? It is very important. See, when you don't have the knowledge of the lone pairs present on the respective different kinds of the atoms, then you won't be able to write or draw the correct mechanism of any reactions. And from the basics of the inorganic chemistry, you are much aware about the fact that the oxygen is always having the two lone pairs on it when it is in the neutral state. So here you see this group is the neutral, so two lone pairs are present on the oxygen atoms of the glycol as well as on the oxygen of the carbonyl group as well, okay. And you know this carbonyl group is basically positively charged. It's a nucleophilic center, right? So it undergoes the nucleophilic addition reaction, okay. And so this will attack, actually this is actually your nucleophile, right? This is your nucleophile, and that nucleophile will attack on this electrophilic carbon. That carbon is the electrophilic in nature, that's why it undergoes nucleophilic addition reaction. Please remember, this will be positively charged, that means it is nucleus center, okay, and this is the nucleophile which will attack on it, okay. So intentionally I have drawn or I have written this OH group in that manner because I need one of the oxygen pair from the either of the hydroxyl group to start my reaction, okay. So what will happen, say for example, this will attack on this carbonyl carbon and this will get shifted over there, and when this will happen, you will have this particular compound, right, Br at the beta position. This is your beta carbon, this is your alpha carbon, and this is your carbonyl group. Of course, two lone pairs were already having on it. One has come from the shifting of the pi bond, okay, which was earlier present on the carbon and the oxygen. This is the hydrogen, and now this will make with the bond with this oxygen, and this is the hydrogen, of course, okay. And this is your CH2, there is no problem in that, okay. And you see another CH2 is here, and then my OH group. This will have the two lone pairs on it, and this will have only one lone pair because one of the lone pair was used in the formation of the bond with this carbon, actually. So this will get the positively charged. This is the first step of the reaction, okay. Now you can see here, this is the negatively charged center, and it is having this oxygen which can be very easily grabbed by this negative charge. Basically it's a intramolecular hydrogen transfer, Okay, so how this will grab? So this pair will attack onto this one, and this lone pair will be originally shifted to this again. Okay, carbon, and then you will have here this intermediate, that is Br. This is alpha carbon, this is your beta carbon. Now this is your oxygen with hydrogen. Okay, now this is basically alcohol you have produced here. This is your hydrogen here, and now this is your oxygen with the two lone pairs on it, and of course this is your CH2, right? And this is your another CH2, and say this is your OH. I am writing in that manner. Okay, now you can see in this particular stage you are having one alcoholic functionality here and another functionality OH functionality here. Okay, and you have used, or you are using sulfuric acid in it. That means acidic environment is always there. So what will happen with this alcoholic environment, right? So this is say H positive. Yeah, sorry. See, since you have taken this sulfuric acid here, so it will have the acidic environment. That means H positive is already there. Okay, so now this H positive has the two possibilities. It can react with that OH group, okay, or it can react with this OH group, because secondary kind of the hydroxyl group, because this carbon is connected with one carbon here and one oxygen here, right, while this one is the primary one. So obviously this is this OH group is much more reactive than this one. So what will happen in that case? Again, you see this OH will attack on this particular group, and then you will have your this functionality. This is say your Br, alpha carbon, beta carbon, and then this would be your OH2 now with a positive charge and only one lone pair, and of course this is your hydrogen present on it, right? This is your oxygen with the two lone pairs, and this is say your CH2, and this is your CH2, and this is your OH basically. So this species you have produced here. Okay, very important. And you know the very important role of the sulfuric acid is what? The role of the sulfuric acid is basically the dehydration. It will do the dehydration. That means water molecule will be removed. So this step is basically the protonation of the alcohol, and after the protonation you will do the dehydration of the alcohol. So what will happen? This will be pushed over there, and your water molecule will be removed from here. Okay, and then you will have your this species Br with alpha carbon, then your beta carbon, right? And this is hydrogen here, and say this is your oxygen, right? This is your CH2, then again you are having the CH2 and then the OH group, and now you can see here this is the positively charged species. So this is a kind of the carbocation. Okay, so you have produced this carbocation from here. Now this step is very, very important. This is the protection of the carbonyl group. How we do the protection? For this, actually what you need to do, you need to number the centers as well. So for example, I am giving number 1 to this particular carbon on which actually, sorry, it is not clearly visible. I am giving number 1 to this particular carbon on which this positive charge is present. Okay, and say this is oxygen is your 2, and this carbon is 3, and this is 4, and this hydroxyl group is 5. So basically you are having these 5 atoms attached to it. Okay, so it simply means the protection is taking place, and you will form a 5-membered ring. You will form a 5-membered ring. So how this 5-membered ring will form? See, now this the two lone pairs which was present here actually, okay, this will attack onto this particular carbon. When this will attack onto this particular carbon, so it will be now a closed type of the ring. Okay, ring closure actually is taking place here. So 1, 2, 3, 4, 5. That means you are now producing 5-membered ring. So I am producing my 5-membered ring in that manner. Say this is my 5-membered ring. Simply you have produced 5-membered ring, and then you can number this 5-membered ring. Okay, say this is carbon 1, this is carbon 2, this is carbon 3, this is carbon number 4, this is carbon number 5. Now you can check in the reaction. This your carbon 1 actually is undergoing the ring closure with the oxygen. That carbon 1 will be connected to the carbon 5 with oxygen. So this is your carbon 5. That means oxygen must be here. So I am writing my oxygen here. Okay, and you can see here this oxygen is also having the H group. So I'm writing my hydrogen as well here. There is no problem in that. And you can see my atom number 2 is my oxygen. That means this atom 2 is the oxygen. So I'm writing my oxygen here. This is my oxygen, okay. And then you can see here at carbon number 1 you are also having this particular branching. At carbon number 1 you are having this particular branching. So I am giving that branching here, just like that. This is your beta carbon, this is your alpha carbon, and this is your Br functionality, like that only, okay. And here you can see this is also having the presence of the hydrogen here. So I'll write my hydrogen here. So this I have produced, okay. And this is basically the protection of the carbonyl functionality by using the ethylene glycol. So up to this step you have protected. Now you have protected this particular group, and this will be reproduced after the reaction. You see here this lone pair has been used in the formation of the bond with the carbon. So this has now neutralized with this bond, but this oxygen will now the electron deficient. So positive charge we need to put onto this particular oxygen atom, okay. Now this is quite clear, okay. So this is very, very important. So now what will happen, since you are using in this reaction you are using your H positive, that means acid is already there, it will be reproduced. Acid catalyzed reaction is there, so HSO4 definitely would be there in that case. It is coming from the ionization of this one. So this negatively charged species will grab this hydrogen here, and the bond which is present here, it will be pushed back onto this oxygen atom, and your sulfuric acid would be reproduced. This is the usual way of the dehydration of the alcohol, okay. And then you will have this species, very important, oxygen, and then your oxygen again, and say this is H, and this is your Br. Up to this step there is no problem, okay. And now we have produced this particular neutral species, okay. This is quite simple now. Now this is basically your A. This is basically your A. So I'm writing this species as A here, okay. Now what will happen, this A will react with the magnesium metal in presence of the dry ether. It is simply the preparation of the Grignard reagent. If you haven't protected, see this particular carbonyl group with that one, so what will happen, this will react onto this carbonyl group, this will not react with this one, right. So now since we have protected this carbonyl group, this magnesium will obviously form the Grignard reagent with this end actually, okay. And now you are doing this reaction, okay. You are using magnesium in presence of diethyl ether dry, okay. Now this is basically your Br. This carbon is actually now positively charged species, and in the Grignard reagent this magnesium will insert or will add to this particular carbon atom, this magnesium, please remember, okay. So this is my oxygen, this is my oxygen again, okay, and this is my hydrogen here, and now this is my bond here, and this is the magnesium and Br. Simply this is your Grignard reagent, okay. What? This is your Grignard reagent. I am writing Gr for the Grignard reagent, okay. And when the Grignard reagent forms, this magnesium is what? It is basically magnesium in the ionized state, which is 2 positive. When it is 2 positive, it simply means 1 negative is over there, and definitely this carbon would be negatively charged. Now in the next step, if I go back, since now you have produced, you have reacted this. You have reacted with this mechanism, magnesium with this particular carbon to form the Grignard reagent. Now you are having this reagent, okay. So what will happen? Now I am drawing mechanism like that only. Say this is my benzaldehyde, okay. This is phenyl group, and that phenyl group is now connected with the oxygen and this one. Again, what you can see here, this is the after the shifting of this electron cloud, this will be positive charge, okay. Nucleus center, that means it is basically positively charged. So basically it will have the affinity to the affinity for the negatively charged species, okay. So this is the concept of the electrophile nucleophile, okay. And this carbon is basically nucleus loving, so this is acting nucleophilic, and this carbon is the electrophilic. So this will attack onto this carbon, and this will attack on this carbon, then it will result your another very important species, and that species would look like oxygen, oxygen, and this is the hydrogen here. Please remember, right? And this is your Mg and Br. No problem in that. And now this is formed with this bond with this carbon. This will form bond with this carbon. Okay. And here you can see this oxygen would be negatively charged, because when it will attack on when this will attack onto this one, this will shift here. Okay. So I'm shifting this here actually, so it will get negative. Of course, if you want, then you can draw the lone pairs as well. No problem in that. And this is connected with the hydrogen here, and this is where this particular group. I hope there is no problem in this particular. There is no problem. Okay. Now again you can see here. It is very important. This was your, say, earlier what happened actually. This is your carbon, and that carbon is having what? Hydrogens attached to it. Okay. So two hydrogens must be there actually. Okay. So I'm writing the two hydrogens here. One hydrogen is this one, another hydrogen is this one. So what will happen? This negatively charged species will grab this hydrogen from here. So I am drawing the mechanism in that manner, or electron shifting. This will grab this hydrogen here. Okay. And when this will grab this hydrogen here, so what will happen? You will end up with the, basically it is a kind of the protic workup. Okay. It is a kind of the protic workup. So first of all I am drawing this species, right? And this species is this is your oxygen, this is your oxygen again, right? This is your hydrogen again. Okay. And this is your this one, and this is your MgBr. Okay. Now this is your phenyl, of course carbon is there, and this is where OH now, and this is your hydrogen. There is no problem in that. I hope it is quite clear to you. Now I will do the deprotection. How I will do the deprotection? For this I need to go back. Basically this B we have produced here. This is basically your B. So what you can do, you can write this as B. Now you can see this B will react, will undergo the hydrolysis, acidic hydrolysis. This HCl, you are taking HCl here, and this is aqueous, right? So what will happen? Now the deprotection. This will do the deprotection. I'm writing deprotection here. Deprotection. So how the deprotection would occur? It is very important to understand. Basically, what will happen? This bond will cleave from here. This bond will cleave from here. So since we are doing this deprotection with the help of the water, so this is OH, this is H, and here you are having OH here. Similarly, this is H, and again you are having this OH. So this bond will break, and you will reproduce your glycol, which you have used for the protection. There is no problem in that. I hope this is quite clear to you. Okay. And since you are taking this one, definitely here also you are having H positive and OH negative. Water is also there. Okay. So now you have removed this one. So what will happen? See, when this group has removed from here, now this carbon will carry the two OH group. One OH is this one, and another OH this one. Okay. Along with this particular hydrogen. Okay. And here you can see this MgOHBr will be removed. So I'm writing my MgOHBr. Okay. And the hydrogen actually will go onto this particular carbon. So this will become CH2 now. Since I need some space, so I am removing this thing from here. And so MgBrOH will be removed, and this will form another intermediate. Let's say what kind of the intermediate it will form. Functionality, this one. Okay. And this is my CH. There is no problem in that. Okay. And this CH is connected with the OH here. You can see here. This system I have already made. Now this is connected with the carbon here. which is nothing but CH2, right? Here, this is connected with this one. This is your CH2. Another CH2 is here. No problem in that. And finally, this is my CH, and that CH will have the OH and OH. Two of the lone pairs onto this one, two of the lone pairs onto this one, two of the lone pairs onto this one. Okay, so what will happen? This OH will grab H from here, and this will be pushed back onto this particular system. So minus H2O you have removed from here, and then you left with this product, which is this one. This is your CH. Of course, this OH is attached here, and this is your CH2. This is your another CH2, and this would be now your C double bond OH. Right? So this product you will form here. So basically, this is your product C. This is your product C. Okay. So you have completed with this particular reaction. So I have already told you when I have started this particular reaction, since we are doing the protection of this group, then this will be reproduced at the end of the reaction, and you can clearly see here this group now has reproduced. Only this alcohol functionality we have added here. I hope this is quite clear to you. Okay, so if you enjoyed the lecture, understand the things, right, then please like this particular video, and if you are watching video for the first time, then please subscribe the tetrahedron chemistry classes and do share with your friends as well. So that's it for today. Thank you very much.